are very slightly light blue, maybe even, huh? Nice stones. They did not start out as a large stone like this and get cut into a bunch of smaller stones. They started out as little tiny crystals, little octahedral crystals, usually, these sized stones, and they cut them in half. And the flat part in the top here is the middle of that octahedral crystal. And so that's what people are used to, because that's what De Beer sells. And they're all pretty much little like this, and perfect, and you've seen one, you've seen them all. And these are really nice stones. Don't get me wrong; they are very, very, very nice stones and beautiful. And mine are probably better than most, actually. Um, and they come from a crystal similar to this, just not in exact shape. They have three crystal axes. It's a cubic crystal, okay? So you can sort of see the cube there. And its symmetry is cubic. And these back here are the growth lines of the crystal as it was growing, and it in fact grows not in little hexagons but in little cubes. And I'm gonna blow this up, and we're gonna look at that, and you can see the crystal structure in there in little cubes as these lines line up. Watch. And these lines line up. Let me see if I can get this to shine here for us, huh? These lines line up according to those three crystal axes of a cube. They're equal axes, okay? A cube, right? A cube is equal, about as equal as you can get. Okay, it is cubic, and cubes um, are part of the octa. Well, the octahedron is kind of a takeoff on that. But what it comes from is the cubic, the carbon atoms are not like silicon dioxide, for instance, in quartz. There's two things, right? Silicon and oxygen. Carbon is just carbon, right? It's just carbon. And so this crystal structure comes from those carbon atoms being smashed together so tightly that we can now see through it. Graphite, the stuff in pencils, is the other form of carbon. That's how carbon looks when it's not smushed together. It's black and opaque. These crystals are made up of little cubes that have it's called close packed cubic. It means there's one in the center of four. They're as close packed as they can possibly get. And what happens is one atom is surrounded by 6 other atoms in a plane. And then there are 3 on top and 3 on the bottom that connect it to the next plane upwards or downwards. And the stacking order of that determines whether it's a cube or a hex. And you get close packed cubic in one instance, and it's just the shifting of the top and bottom atoms, right? There's still 6 atoms around each atom in what we call close packed hexagonal. In opal is the spheres in precious opal are close packed hexagonal, or sometimes close packed cubic. It depends on the stacking order of those top and bottom atoms. So here we have a carbon crystal that's 6-sided, but it has 4-sided symmetry. Watch. This is the z-axis. See, this isn't a crystal sticking up this way. It's a sideways crystal. And this right here, this point right here, is the top. And you have 4 planes coming up to that in a pyramid, right? That's the beginning of an octahedron, or one of these. That's what this is. And so I know this is the z-axis, because when we look down it, as I shift this around, you can see 4 different views of the inside of that crystal. It's because of the 4-sided symmetry of a cube that it does that. And it's so dense, it looks like things are magnified in there. It's just because the light bends so strongly, and it fools your eye because it's so very, very, very clear. So this crystal shape is found in Herkimer diamonds, and I'm beginning to think that maybe Herkimer diamonds are actually diamonds, but I don't know. These are, and you can see it with the crystal axes back here on this face of this crystal. Lights up that way, lights up this way, and then of course it lights up this way over here with this axis. And this, when I look down the z-axis, the whole crystal will light up. Watch. Hey? Isn't that cool? It lights up because those axes, the axes catch the light and bend it so strongly. It stays inside that crystal, and they seem to glow from within. Diamond is not like anything else because of the density of the crystal structure. And there it is, lighting up for you. There it goes. Let's see. Here we come. These flaws, I guess they're called. There's where you can see some of the structure of the crystal on that face. Those are growth lines. And when you magnify this and get closer and closer, those are made up of little tiny squares. And they sparkle. Look at that. They break the light because they just turn into smaller and smaller and smaller squares right at that level that breaks light into a rainbow. Whoa. There it is. Whoa. I'm a crazy man. There is no doubt about it, man. I'm crazy about these things because they are big fun, man. I am having big fun here. Peace, y'all.